Our speaker is as I mentioned, a graduate of John Nevins Andrews High School in the Washington, D.C., Tacoma Park area. He went on to Washington Adventist University, and from there he went to MIT. For 20 years, he was at Los Alamos, the Lawrence Livermore National Laboratories, and his background from college is in math and physics. He is a nuclear physicist and a specialist in nuclear weapons. In 2006, he became the director of science, technology, engineering. He was the associate director of the lab, but was in charge of the science, technology, engineering area. He was so well loved by his colleagues that when there was an opening for the directorship, they pressed him into duty, and he became, in 2011, the director of Los Alamos National Laboratories. The core mission of that lab is ensuring safety, reliability, and performance for the nation's nuclear deterrent, and the safety of and security of our nation is greatly held in the palm of his hands and his marvelous team that's around him. Many of you have seen his very nice TED Talk dealing with the importance of STEM education and national security. Certainly his list of publications and awards and honors is very lengthy. He testifies before the U.S. Senate, the Committee on Armed Forces from time to time, and is really an individual who has accomplished so much. And we're delighted to have Dr. McMillan and his wife here today to speak to us. Give him a warm welcome.
Thank you, Ron. I think I'm good to go here. May I borrow your table? I'll put my notes there. It was a bright September morning in 1969. Robert Hatt stood up in front of his Algebra 1 class and said, "Some of you are going to get what I'm going to tell you, and some of you aren't. I'm going to do my best to help you get it." I was one of the lucky ones. I had Bob Hatt for 3 years of high school math, Algebra 1, Algebra 2, and Calculus. And my other high school math teacher, who I just saw last year, was Jim Borchers. Those two men shaped my life. And to me, the challenge that you face today as teachers is, how do you do even better than Bob Hatt and Jim Borchers did? And it's interesting to me, I just found out a minute ago that Bob Hatt's grandson is in the room today. So I'll give you that challenge. How do you do better than your grandfather? And that's what I'd like to talk about, because I think the role you play for the future of this country is an incredibly important role. So all of your students are going to be, in this country's case, future voters. And I think it's essential for them to have at least a fundamental understanding of what's going on. You know, think about the science I talked about. 99% of the funding for Los Alamos National Laboratory is taxpayer money. It's going to be your students' money. It's your money too, by the way. And if they're to make wise decisions about how this country invests its money, they need to understand well enough. So these means, I think, matter to all of us, and I think they matter from a public policy perspective. But now let me talk about the future PhDs for just a second. What I did is, it turns out these data are pretty accessible, and if you want to go play with them, you can just go get them off the web. I said, okay, let's look at the highest scoring groups on the TIMSS test. And in this case, the the way I could get access to the data is they have scores over a certain level, and a fraction of the students who score above a certain level. And the level that they've got is 625. So again, that's the same score worldwide. Now, I'm going to tell you up front, one of my sisters does statistics for the company here in California that analyzes almost all the standardized tests that are given in the country. She knows a whole lot more about the issues of psychometric measurement than I do. And she tells me that things like norming across tests year to year is a very tough thing to do. But for the moment, I'm simply going to make the assumption that the guys who do the TIMSS test have done it right. I can't verify that personally, but I'm assuming they've done it right. And so as I look across years then, what again I see is that for fourth graders, the fraction of kids who are in that highest performing group, and this is now, I can tell you, although it's a little hard to see it here, that that's about 7% of our students. 7% in the highest. So this is like the top 10%. Why don't we think of it that way? Roughly the top 10%. Again, what you can see is that the fraction has gone up over the last. Oh, I'm sorry. This is I'm looking at the wrong score. Let me get to the right one. There we go. Here we go. So these are the high performers. So again, you can see that in the fourth grade, we've got about 12% of the kids that are in this highest performing group. But in the eighth grade, we've kind of leveled off. And that leveling off there is about 7%. Now here, so I'm going to assert your future PhDs are in that group in all likelihood. And my logic goes like this. If they aren't in this group by the time they're in the eighth grade, they're not going to be ready for high school math. How many high school math teachers do we have in here? Okay? If they aren't there, they're going to struggle when they get to your class. That's my guess. And if they can't make it through your classes in high school, they don't have a prayer in college. When they get to physics, when they get to chemistry, when they get to statistics, they're going to be stuck. So to me, this group matters a lot. And if they don't take chemistry, physics, calculus in college, they're not going to be my PhDs. It's just that simple. They're not going to do the stuff we just talked about. Now, how are we stacking up against the Taiwanese on this one? And this one does worry. Look at this. Same color scheme, fourth graders here. Nearly 30% of the kids in Taiwan are scoring above 625 on the TIMSS test. And by the time you get to the eighth grade, half of them are scoring above 625 compared to our 10%. That worries me a bit. That worries me a lot, actually. Now, let me tell you something. When Los Alamos started, there were an awful lot of people who didn't speak with an accent that sounded anything like mine working on the Manhattan Project. They had names like Fermi. They had names like Bohr. Okay? It's still the case at Los Alamos that there are a lot of scientists who don't have an accent that sounds anything like mine. We recruit the best minds from all over the world. And some of those best minds are Chinese best minds. Now, I bet you've heard the same thing I've heard. Well, you know, yeah, they're really good, but they're not very innovative. You know, their education system doesn't teach innovation the way the American system teaches innovation. I got news for you. They're really, really good, and they're very innovative, and they're taking top honors. We can't sit back. We can't sit back. So this concerns me, because if they've got any way to scrape the cream from that, they're going to have some really, really good people that your students today are competing with. And so I'd like to talk about what we do in this area too, because I think there's opportunity. Let me say it that way. One last chart of graphs. The other thing I've looked at, and I think this is important for some of the actions, is what's happening with different ethnic groups here in the U.S. as we look at these trends. What you can see is that for white kids, things have been pretty flat over the last 20 years, haven't changed very much. But for all of our minorities, things are getting better, okay? So for whatever you're doing something that's helping our minority kids. Now, what we see is kind of the ordering that, you know, everybody thinks about with, you know, Asian kids up here, Hispanic kids here, and black kids here. But I would point out that all of them are getting better. And I'd like to try to talk about some ideas about what we could do on that as well. But now I tread on thin ice. I told you earlier, and Ron told you, I have a degree in mathematics, I have a degree in physics. I don't have a degree in education. I am not an educator. Now, the only thing I can say that will slightly redeem me is that I am an educator's son. My mother was a middle school math teacher. So I at least can claim that I watched her teach, I watched her grade papers, and I watched her frustration with middle school math. But I'm not an educator. And so rather than be as presumptuous as to try to tell you all how to do what you know how to do better than I do, I'd like to throw out some options. And what I did do is I did what I know how to do, which is research. So I went and read a bunch of papers. And I think on your desks, you've got a paper that looks something like this. You know, all of these, by the way, are papers I was able to get on the web. And I found them to be pretty interesting reading. I realized from having watched my mother that you guys have very busy lives, so you don't have lots of time to read papers. But these are a few that I'll tell you I did find interesting, and I think you might find interesting as well. Let me show you some of the things I found when I looked at them. And I'm simply going to show these as options for you to think about and consider. Again, I am not an educator, so take everything I'm about to say with a very healthy dose of salt, okay? Because I've never done it. You have. First of all, the issue of what students expect of themselves. There's a fascinating body of research around what's called psychosocial interventions. The guy who's doing this work is a guy named Stephen Yeager. It's reference number 4 on your sheets. But several of the other papers, I think the number 4 reference is a survey article. Now, what I didn't realize until Friday is who funded this work. If you go look at the funding agencies, I think the first funder of this work was the Bill and Melissa Gates Foundation. Now, I want to tell you how important you are. A week from today, at about this time, I'm going to be greeting Bill Gates at the lab. And one of the questions I intend to ask him when he gives a talk to the lab next Monday afternoon is I'm going to ask him about the work his philanthropic foundation is funding in STEM education. But this is work that Bill Gates funded. Here's what they did. And it blows me away that this worked, but it's been reproduced, and they've reproduced it in several different ways. They went to kids and said, take the next 15 or 20 minutes and write about your values. That doesn't sound like very much, does it? And the control in this study was they went to the other kids, and the way they did it, they passed out sealed envelopes with the assignment for every kid. And for the control kids in the class, they said, please write about values somebody else might hold. Sounds pretty simple, doesn't it? They then tracked each of those groups of kids through the next couple of years of their education. And what they found was the kids who had spent 15 or 20 minutes writing about their values had scores that were about a half grade point average higher. And it lasted for years. It wasn't just, it lasted a month. That blows me away. Now, what's fascinating is the guys who are doing this work have said, well, what's going on? Why do we think this happens? And the theory is that all these kids are going to hit rough patches, things that are very hard for them as they go through. And I'll bet you find your students have trouble with some concept. Maybe it's factoring polynomials or prime numbers or what, I don't know. But kids are going to find something that's hard. And when they do, if they appeal back to their values and it's something like, I stick to it, I persevere, then they go and they say, hey, I need some help, teacher. Or they go to a tutor and say, hey, help me out here. Or they go talk to one of their friends in class and say, hey, I'm having trouble with this. Help me on my homework. But whatever, they take action. On the other hand, if they say, well, I'm a girl, I'm not good at math, and they stop, then they're stuck. Because with math, you have to get all the ideas all the way along. And if you miss factoring prime numbers or factoring polynomials, you can't pick it up sometime later. You got to get every step of the way. And it seems that something about this process of writing about their values, the ones they hold, have changed their willingness to tackle these hard problems. And it seems to be particularly important for kids who have stereotypes that are of the form, I'm a girl, I can't do math. Or I'm a black kid, I can't do math. Now, I don't know whether this is something that's worthy of trying, but I would suggest you go look at the papers. I don't think it's a magic bullet, but a surprising amount of research seems to indicate that what students expect of themselves has a big outcome on how they perform, okay? And so if you go back to the charts I showed before that had the gaps on, what can we do to close that gap? Well, maybe something like this is an idea. It's an option for you to think about that really could help you close the gap with your students. And it might help in things more than STEM. I don't know. Another obvious thing is parent expectations. And, I know it to be the case, and I'm sure some of you are dealing with this every day, that you call up parents and you talk to them about how their kid's doing. And the parent says something to you as the teacher like, that's your problem, not mine. I'm sorry to hear that, but I know it happens. As I said, my mother was a math teacher. However, what can be done that can help parents who are willing to engage or who might be willing to engage? This is a study that was funded by the National Science Foundation, and it was done up in Wisconsin. I'm sorry, I think it was in the Wisconsin area. Anyway, I may be wrong about that. But what they did is they said, okay, what can we do to get parents to talk to their kids about STEM fields? And they sent 2 mailings, only 2. They sent them, this was for high school kids. They sent them after the kids' sophomore year in high school, so they'd had 2 years of high school under their belt. And basically the first letter they sent was, why is STEM education important for kids in their future careers? And here, let me just talk about a study that I read last Thursday evening. I want you guys to think of yourself as making future millionaires. This particular study looked at the value of different degrees by field based on, and what they'd done is they basically matched ability levels. So you take 2 kids of similar ability level. One of them gets a high school degree, the other one gets a STEM degree. You want to guess how much that's worth over a lifetime? It's about $1.7 million. 1.7 million. That's a lot of money on average. Now, they then looked at, okay, what about kids who go and get a fine arts degree? You want to guess how much that one's worth? That's worth about $700,000. So the difference between, and these are for kids of comparable ability. So the difference between a kid that gets a degree in, well, I happen to like theater, so I'll pick theater because I do theater. So a kid who gets a degree in theater and a kid who gets a degree in a STEM field is the better part of $1 million. That's a lot of money. And so that's the kind of stuff they were telling the parents. By the way, person who gets a degree in theater, but if they take math classes along the way, their income comes up even if they don't have a STEM degree. So that's also, that's why it's good for everybody, right? So they were telling the parents that. The second letter was, and here's how you can talk to your kid about STEM. So 2 letters, basically about after sophomore year in high school. And they had a website that went with it. What they did is they then said, okay, how many STEM classes do the kids take in their junior and senior year of high school? It turned out, just sending 2 letters to parents, these kids took an extra semester of math or science. And they did it by going back and looking at the transcript. They didn't look at what the kids said, they looked at the transcript, compared to the parents who didn't get one. And it turned out, surprise, 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 the mother was critical in that. They looked to see who, which of the parents was interacting with the kids. It was almost always the mother who was talking to them. So here's another thing to think about. I'll give it to you as an option. Now, what's good about this is, as I said, these kinds of extrinsic motivators, like getting an additional 1.7 million over the course of your life, that's an extrinsic motivator. Parents care about it. Students care about it. And I don't want to underestimate the power of extrinsic motivation. But I would like to offer that intrinsic motivators may be more powerful than extrinsic motivators. Last week, I was talking to the graduate students at the lab. And let's see if I've got it. Yeah, this is the chart I used with them. The grad students are always interested in, well, how do I get a job at Los Alamos? And when I talked to them, I said, hey, it's all well and good to have these kinds of extrinsic motivators. Your parents want you to get a good job, have a lot of money, you're whatever. But I said that is not enough for a job at Los Alamos. You've also got to have the intrinsic motivation, interest, passion, curiosity. I remember, I'll tell you one story, and I think it will illustrate what I mean by this. Several years ago, I took my son to work when he was about 12. We had a family day. I could take the kids in. And we went out to one of the explosive sites. And we had an accelerator that was the size of a football field, and he got to play with, things that look like detonators and all that. And at the end of the day, he said to me, Daddy, you used to have the perfect job. I'd gone into management by then. Daddy, you used to have the perfect job. Why did you ever give it up? Well, that's the way a lot of these people feel about their job. They have the perfect job, and they haven't given it up. Okay? That's what it takes to really, in my view, have a successful career in STEM areas. So I'd like to talk for a second about what I think of as intrinsic motivators. Things that are so fascinating you just can't let go of them. At least that was the case for me. And I'll bet it's the case for some of your students. Now these may be your future PhDs, I don't know. But let me just give you 3 examples. Who in the room knows who Ramanujan was? You know Ramanujan. Who is Ramanujan? G.H. Hardy. Yeah. Trinity College, Cambridge. Yeah, so here's the story. By the way, if you want to read the story, and you got it, there's a great book called The Man Who Knew Infinity by Robert Kanigall. Kanigall taught writing at MIT for about a dozen years, And for a non-mathematician, I thought he did a really nice job. But yeah, you're just right. Ramanujan was an Indian kid, came from a lower middle class Indian family. His parents didn't have any particular advantages at all. He was obviously a bright kid, did well in grade school. When he got into high school, breezed through high school, and toward the end of high school, he managed to get his hands on a book of mathematics, only one, believe it or not, that was used in prepping English students for graduate level math exams. And he became fascinated by it. He got a full scholarship to college and flunked out. Why did he flunk out? He was addicted to trying to figure out infinite series. He started writing to mathematicians in England, asking them for help. And his math was so advanced that people thought he was crackpot. They couldn't understand what he was writing. By the way, I get those kind of letters too. When you're in prominent positions, you get interesting letters. Anyway, people thought this guy was a crackpot. And he finally sent a letter to Hardy, who was probably the preeminent mathematician in England. Hardy was at Trinity College, Cambridge. When Hardy got it, he got together with one of his colleagues in the math department at Trinity, a guy named Littlewood, and said, come look at this. And they sat down that night in their rooms at Trinity College, and they looked through this, and they said, it looks like there's something really here. And it was math they had never seen before. And long story short, they corresponded with Ramanujan, ultimately convinced him to come to England. This was during the First World War, so he came to England in 1914, just before the war started. Within 3 years, he was a fellow of the Royal Society, one of the highest honors that England can give in the sciences. He was a fellow of Trinity College, Cambridge, and a very sick man. He went home to India and died within a few months. His notebooks that he produced from the time he was in high school through his time with Hardy and Littlewood at Trinity in Cambridge have been a rich source of study for mathematicians for a century. And we still don't understand everything this guy had in him. And this was a lower middle class Indian kid with no advantages. Somewhere in your classes, there's a Ramanujan. I don't know where he is, but somewhere there's a Ramanujan. This guy was amazing. And it's a great story. I recommend it to you. I remember reading this story, not Conegal's version, when I was in high school and being inspired by it. So think about what are the role models you can provide kids. And I would suggest Ramanujan is a pretty interesting. I'm going to skip to the guy on the right. Anybody know who George Cantor is? Okay, who was George Cantor? You win the pop quizzes today. He was Eastern European, I believe. Mm-hmm. Exactly. Well, and so let me tell you my personal story on Cantor. When I was a senior in high school, one of my English assignments was to go do an interview with somebody about their career, and then write the interview. So the guy I went to talk to was a guy named Gary Gleason, who's a mathematician at the local college, the one you mentioned, as a matter of fact. And I went and interviewed Gary about his job. And Gary spent the whole time talking to me about what's called Cantor's continuum hypothesis. Now, for those who don't know what the continuum hypothesis is, what Cantor showed was that there are different sizes of infinity. And it's pretty easy to prove that there are different sizes of infinity. I won't give you the proofs right now, but if you ask me later or ask him, I'll bet he can show you. But just to give you, an idea, the size of the integers and the even numbers is the same size of infinity. But the size of the even numbers, or the integers and the reals, is different. There are more reals than there are integers. But if that doesn't warp your mind, I don't know what will. And I can prove this to kids in grade school. It's an easy proof to do. And what I find is kids just get fascinated by this. They can't put it down. It's kind of like you said, they go crazy. And that's what I wrote my interview on. And the continuum hypothesis, I forgot to tell you what it is. The continuum hypothesis is, do different sizes of infinity come like the integers, 1, 2, 3, or are they like the reals, that between any two there's another one? It turns out you can't prove it either way. So you get to pick. And this is the beauty of mathematics. Mathematics is all invented. And so you pick whichever one of those you think is more interesting, and then you build your mathematics on. Okay? That was the continuum hypothesis. But you know, that kind of stuff, kids don't learn that. And yet I look at that and I find it fascinating. To me, it's intrinsically interesting that there are different sizes of infinity, and it's easy to show. Because it seems like that wouldn't be the case. And so what I put these up here as examples of things that can draw kids in, or may be able to. So let me give you my third example. Carl Friedrich Gauss. Gauss invented a lot of things. We know him from the normal distribution, which we call a Gaussian, right? But we also know him from the invention of linear algebra. And for me, it was mind-blowing to find out that there were different kinds of mathematical structures than the ones we know and love. So the one we all know and love is called a field, right? It has two operations, addition and multiplication. It has two identities. 0 is the identity for addition, 1 is the identity for multiplication. And both of these commute. So a plus b is equal to b plus a times b is equal to b times a, and they distribute. A times b plus c is a times b plus a times c. That's a field. There are all kinds of other mathematical structures. So the particular structure that Gauss developed involves a group. And groups don't necessarily have all these properties. So in the case of linear algebra, matrices, addition commutes, but multiplication doesn't. A times b is not necessarily equal to b times a. And the fact that these kinds of different, and there are all kinds of other groups. For example, the rotation group. You know, if it turns out the rotation group is non-abelian too. If I rotate this way and then I rotate this way, I get a different answer than if I rotate this way and then rotate that way. Okay? So the rotation group is also a non-abelian group. Abelian just means it commutes. But there are all these kinds of very simple mathematical structures that kids don't know about, but they could. Well, no, they are. They're very simple structures. But kids think there's only one answer, right? They think a times b has to equal b times a. Well, what if it doesn't? What if it doesn't? You get a completely different mathematics. And so I remember, my dad was a physicist, so I guess I come by it honestly. But I remember him teaching me how to multiply 2x2 matrices together and not teaching me how to invert them and leaving that as an exercise for the reader. And that fascinated me for weeks, trying to figure out how to invert 2x2 matrices to get the identity. Well, kids can do that. I did that when I was in the 7th grade. You can do it. So what do you give your kids that draws them into sort of this broader, that inspires them? I guess that's what I'm looking for. Where's the inspiration that will get them so interested that, like Ramanujan, well, hopefully not like Ramanujan, they don't flunk out of college because they're so interested in it. But they can't put it down. They have the passion. So I would suggest that in addition to the kind of extrinsic motivators that I think all of us as parents and as teachers think are important for kids, how do we get the intrinsic motivators that are just going to suck kids in and they can't let go of it? That's a challenge for you. So let me wrap up with just a couple more slides. As I think about what we do in STEM, and remember, I'm not an educator. You are, I'm not. There are three things that seem important to me. And expectation is at the middle of all of this. But how do we enrich the lives of these kids? You know, whether it's going to science museums, doing the kind of stuff you're doing this week. I view what you're doing this week as enrichment for the kids you teach. Inspiration. Well, I gave you a couple examples of things that I found inspirational, and who knows? You know, maybe you can find some others. I fervently hope you can find better ones than I could find. And then encouragement. And here I put some of the things like I started talking about, of letting kids think about their values. What is it that will help them when they get to a hard place in their educational career and it's tempting to give up? And you know, the right word at the right time keeps them going so that they have an option. So for me at least, inspiration, encouragement, and enrichment are ideas that I would suggest to you as teachers, as well as parents, as something to think about. Challenge. Turns out I have responsibility for one of the Department of Energy's 17 laboratories. The stories I just told you could be told by the directors of the other 17 national laboratories. Many of these are devoted to energy. 3 of them are devoted to national security. All of these people, all of these great laboratories need people. They need your students. So my challenge to you is, in addition to working on the issues of the average, preparing the nation's future citizens, I'd like to challenge you to produce 2 PhDs in STEM in the course of your careers that you send to me. Now, I don't mean just me, I mean the Department of Energy. But why is that not a crazy thing? Well, as I mentioned, I've got a bunch of postdocs at the lab right now. Right now, I have about 400. That means they're typically there for 2 or 3 years. That means I need between 100 and 200 PhDs per year in the STEM fields. There are about 100 of you. That means you'd be getting me about 1 year's worth. I need your help. If you can send me 2 PhDs over the course of your career, that would help. And I don't think that's an unreasonable thing to do. If you can find me a few Ramanujans, I'll take them. So with that, I'll take questions.
Test 1, 2.
Yeah, it's
Test 1,
working.
2. Okay.
I can hear you.
Just from your introduction, I have a question for you. How close is Iran?
So let's see. I can't quite answer your question. I can't quite answer your question. Let me say it a different. Let me give you a different kind of answer that will I think maybe help. As I mentioned in my talk, the laboratory is engaged in all things nuclear. And so when you hear about countries, and you pick your favorite one around the world, that might be interested in working toward getting a nuclear weapon, you can bet with high confidence that the lab is probably working on understanding what's going on. And I'll give you an example from Iraq a few years ago. I'm looking around the room. Some of you will be old enough to remember this, some of you won't. But back in 1991, the IAEA had a team that went into Iraq because we thought they might have or been developing nuclear weapons. The guy who is the deputy for one of my and you may remember that there was a bus that they had there that got stuck sitting on the pavement, and the guys were trapped in the bus for about a week, and they were using their satellite phones. I know several of the guys who were doing that. That's the kind of stuff we do. So I won't answer your question as you posed it, but I will tell you that if nuclear is involved, Los Alamos is involved. How's that? Yeah, right back here. Yeah.
Thanks. So I have a question around any kind of collaboration or integration that may be possible between these kinds of laboratory sites and K-12 education?
Boy, great question. Go ahead and finish your question, and then
Yeah,
I'll answer for you.
For myself, and I'll just speak from my personal experience, I
Mhm.
didn't know that these particular kinds of laboratories existed until I got to college. And I think that's probably the case for a lot of us, because they're not presented as career options for young people. When you think science as a fifth grader, you think, I'm going to grow up and be a doctor, a medical doctor, maybe a dentist. But very rarely does research really enter into the equation in the earlier years of education. And so I'm just wondering how we might be able to change that and how we may be able to partner with laboratories like yours to do that.
As I said, great question. So I'll speak from my laboratory because I know what we're doing. First of all, just as here you're doing the EXSEED conference, we have something that we call the Math and Science Academy at Los Alamos, and it's aimed at teachers like you, and we provide pedagogical tools in that. We can actually do outreach from the lab to schools we focus on northern New Mexico because that's where we live. But we do that at the elementary and the high school level. Second, we provide summer employment opportunities for students. Right now, I have at the laboratory about 1,000 students, not postdocs, 1,000 students. Most of these are college and grad students. Some of them are high school students. As a sort of a corollary story, the laboratory cares deeply about education. And the laboratory employees have something they call the Los Alamos Employee Scholarship Fund. And they competitively select students from around northern New Mexico to receive those scholarships. And part of what I do for those students is I guarantee from my office 20 of them will get internships at the lab. We provide funding for 20 of them. So those are high school kids headed off to college. So if you have students, particularly as they start to get toward the college level, because that's where we can really work with them best doing science, make them aware that these laboratories exist, first of all. My laboratory is not unique in having a summer program. And what we try to do with those summer students is get them engaged in doing research at appropriate levels for them, so that they can learn something about what research life is like beyond medicine and dentistry. Okay? And if you can't tell, I'm pretty passionate about what we do. And I think getting kids to see that early in their potential careers and getting them working with first-rate scientists can be very inspirational. And so we do it. And something like close to 70% of our PhD non-management hires come out of the student and postdoc program. So overall, we've got probably close to 1,400 students and postdocs at the lab right now. And the summers are really exciting because those students bring a lot of energy to the lab. New ideas, energy, it's really fun during the summer. It's almost like a university. Question over here.
Yes, while I'm coming over, Charles, we have a request to get a little more volume on you, but there's a feedback.
Oh, okay.
So where's the best place for him to stand?
I'll speak up, and I'm going to wander around, but I'll speak up. I can do that. I could do this without a mic, so I'll speak up. Yeah.
Thank you for a great lecture. I worked for Brookhaven National Laboratory for
Great.
11 years, and
Great.
over there we shared the same passion, the same problems, and wonder if there is some common interest in this in the national laboratory level. Why it is not a national initiative with all the laboratories to put together a STEM program, just addressing exactly the point that you mentioned today. So the kind of pipeline of scientists that will feed and the laboratories, for example. I think it's kind of lacking for many years.
So excellent question. And for those who don't know where Brookhaven is it six or it's one of these up in here? I can't quite tell. Yeah, excellent question. Let's see. Let me give you a couple of half answers, but they aren't a real answer. Half answers are that the new Secretary of Energy, Ernie Moniz, who, for those of you who don't know Ernie, was a professor for many, many years at MIT, has been actively working to bring the laboratories together. And he has something that's called the Laboratory Directors Council, the National Laboratories Directors Council, which I sit on, as well as something called the Laboratory Policy Council, which is made up of 4 of those directors: National Security, Science, Energy, and Environment. And I also sit on what he calls the Lab Policy Council. So I'm going to be going to Washington next week to meet with Ernie on lab issues. And among the issues that we take on are thinking about things like workforce for the future. So let me give you a partial answer now to your question. As part of those groups, one of the issues we're specifically looking at, and we're doing this in early July, is diversity in our future workforce. We don't see the diversity we think we're going to need over the next 20 to 30 years in our workforce. And so we're going to be looking at that as a group across the 17 labs in mid-July. And so in a way, that is an education-like issue. And my personal view on that is we aren't going to make progress on diversity if we can't make progress on that in our postdoc pool. Because so much of our hiring comes from the postdoc pool. If we can't make progress there, we won't make it later. I think one of the challenges that we face, to your question about a broader initiative on education, is that many of us are dealing with regional issues in education. For example, for those of us in New Mexico, the issues around Hispanic population, and because we draw something like 40% of our workforce from the local New Mexico population with very strong Hispanic background. So how do we address that within the Hispanic cultural setting that we face in northern New Mexico? It's probably a little bit different than what Oak Ridge sees, which is a little bit different, Oak Ridge in Tennessee, which is a little bit different than what Brookhaven sees in New York. So I think some of the issues are regional, but issues like diversity, I think, are much more national issues. Yes?
I live in northern Idaho, and last week I attended my 4th iSTEM program
Great.
that they've done.
Up at INEL.
Idaho National Labs is doing. Well, they did 6 of them around the state simultaneously.
Right.
But it was all fun. A lot of the funding came from INL.
Mm-hmm.
And I was just wondering, do other national labs do the same thing?
Yes.
For the state teachers? This one seems to be locked into just teachers from Idaho, which I look at your map up there, Montana, Wyoming, Utah, Nevada are all, they don't have national labs.
Yeah, that's right.
But do other national labs sponsor similar programs?
Yeah, absolutely. At Livermore, for example, they do something that they call Science on Saturday, which brings kids into the lab on Saturday mornings and does inspirational talks about the work that the kids are doing, the scientists are doing at Livermore. As I mentioned in response to the question back there, we have what we call the Math and Science Academy for teachers in New Mexico. So, but again, it sort of goes back to the answer I gave to the question over here, that a lot of these issues tend to be regional issues rather than ones that we can easily address further afield. So that's, of course, why we see INEL doing stuff up in Idaho. Right. Yep. That's the problem right there. Okay, back here.
I was very interested in the graphs you were showing, 4th grade, 8th grade, and so on, and your comment that I believe it was if by 8th grade they haven't had certain experiences in math, they're not likely to become a PhD in the STEM fields.
It's hard to catch up, I think.
Well, and we've heard research, not quite like that, but very similar here on this campus. School of Medicine has shared with our president with us that, let's see, I think theirs is if by 6th grade students have not yet made a decision to go for professional school, they're not likely to make it. And then when we shared that with dentistry, they said, oh, we have study that says that if it's not by 5th grade, they're not likely to make it. So my question is, we see that a whole lot really needs to happen in elementary. What can we encourage our teachers here and beyond to help fill this gap and to help inspire our students elementary?
Yeah, well, I agree with you anecdotally because I haven't found the research, but I didn't go look for it. But I do think, something around 5th or 6th grade is a really important time. So those of you who are teaching elementary or, maybe starting to get to middle school levels, I think play an incredible role in whatever decisions the kids are going to make. Now, I don't really know the answer to your question. I've given you a few things that I think can be inspirational. I found inspirational in some cases, but I don't know. I watch a lot of kids, and I think much of what we learn by doing. So, the ready availability of computing technology for kids today, that could easily be a path into these kinds of fields. If you think back to the 40s and 50s, it was something like amateur radio, right? Well, that's kind of KF6XJ. But that's probably not where it is today. But you look at the things that are easily available for kids to play with, things like a Raspberry Pi. Let me just pick an example. It's like a $35 computer. If you mess it up, what really bad is going to happen, right? But you can do all kinds of stuff with the thing. The ready availability of iPads, laptops, you name it, getting kids into programming, because that, at least for me, that's one of the closest things to creation ex nihilo I can think of, because you start with a blank screen and you end up with something that does something. That's amazing to me. So maybe there are ways to get into that. I don't know, but I don't know the answer. That's a place where your expertise is probably more important than mine. There. Okay, and I see another question back there. By the way, grandson of Robert Happ.
As a high school science teacher, I'm getting a little depressed hearing that by the time they get to me, it's too late. If they don't get it by 5th or 6th grade, so am I just
superfluous?
Continuing on where they're at? So I guess my question is, we're hearing that these decisions 5th, 6th grade. So as a high school science teacher, what is my role? Or maybe the other question is, what is it that I can do to make a difference?
Well, so I'll go back to where I started. I mean, your grandfather made a huge difference in my life, but I was a kid who was already headed that way. So again, I'm gonna plead the I don't know question, but let me throw out some ideas. I think it's easy for kids to leak out of the pipeline at any point along the path. And if you can't keep the kids in, then we've lost them for later in the pipeline. So my view is your job really isn't any different than the 5th grade teacher's job. But your problem is that by the time they get to you, some of them have already leaked out of the pipeline.
More like the miracle growth.
Yeah, maybe.
Elementary school teachers plant the seed, and it's my job to
Yeah, maybe that's a way to think of it. But if you lose them, then they're lost when they get to college. If you haven't gotten them through some kind of calculus or whatever, they're going to suffer when they get to physics in college. They're going to struggle with chemistry. So.
We have truth now.
Oh, okay.
So Charlie may not have thought of this, but I'm going back to your question about elementary school. When our son was in 4th grade, they invited parents to come in and talk about what they did for a living. And I hope you guys are all accessing those wonderful resources. And my husband, who was doing what he would call real science at that time, he was doing experimental things, came in and he said, I blow things up for a living. And all those little boys in 4th grade, they said, wow, I want to do that. So I hope you're using your resources of parents who are in these STEM fields to come and talk about real work. Because oftentimes when you come through the advanced school system, you grow up thinking, I'm going to be a preacher, a teacher, a doctor, or a nurse. And I'm sorry Charlie's little movie didn't show up and with the soundtrack, but there are so many other opportunities out there that often people have no idea about. But a lot of your parents who are in those STEM fields, they'll be able to fill in those areas that you might not be familiar with because they've done those graduate specialties, so they'll have a different perspective. So be sure and use them because often they're very accessible and they're really willing to share.
So I'll take one more question here because I looked at the calendar and I think I'm supposed to be done by 10:30. So
Well, I see two hands, so maybe we'll give enough time
I'll
for
let
two.
I'll let you pick.
Just a quick comment. I'm one of those Hispanic students that failed 5th grade math.
Oh, really?
And by the time I was done with 8th grade, the math teacher that I had took me 6th, 7th, 8th grade, and we were doing algebra.
Mm-hmm.
We were doing, he invited a university professor from U of A, University of Arizona, to come in and start teaching us some of these flip ideas, these non-Albion ideas.
Yeah.
And I loved it. And
Yeah.
now
You're hooked.
I'm hooked, and I'm in a school. I'm teaching statistics. I'm
Great.
teaching algebra 1. So I know that you can motivate a student early on in 5th grade, and take them as far as they're willing to keep working.
Right. Well, and what I love about your story is it's the intrinsic motivation that I think helps get kids over the hard spots. Because I bet none of us ever had any trouble with math at all in school, right? It was right. No, but seriously, everybody has that happen to them. Everybody I know. But if there's something that says, but this is so cool, I want to figure it out, then you can get there. And to me, that's the best answer I know to your question is, what is it that's so cool that I just can't put it down? And that I think draws us in. So thank you.
That last comment would have been perfect to end on, but I saw his hand, so I want to be inclusive.
Okay.
So the pressure's on you. This last one is.
All right.
Okay, well, I hope I don't spoil it, but I was just wondering because, we're talking about these guys being on track from like 5th grade and 6th grade, and you being on track when you got to the one class and everything. You work with some of the best people and scientists and everything in the world. What do these people talk about that inspired them and got them going in that direction? Do they have conversations like that?
Yeah,
that
we do,
happened?
and it's almost always a teacher. You talked about a teacher. I started talking about teachers. Personally, I was lucky because my dad and mother were both in technical fields, and so I kind of got it from both directions at home. But most of the people I talk to will talk about a teacher, and it may be just one, but one is enough. And it's a teacher that can somehow convey the excitement, the intrinsic motivation, not just the I want to make you a millionaire kind of message, but that this is so cool you can't stop thinking about it. And so if you as an educator can find a way to do that, I think you will have given just an unbelievable gift to kids. So that's what I hear when I talk to people, and it's almost always the case they can name the teacher. When I had some math teacher, no, they know who it was. So you all play. I said it at the beginning, but I'll say it here at the end. You play an incredible role for the future of the country. Let me just give you what I think the challenge is. I call this the timeline of technology. It takes roughly 20 years from when an idea starts to when it starts to really pay off in technology. It's a long timeline. And when I look back over the course of my career, I'm probably part of the last generation that knows how to use a slide rule. Okay? Yeah, but your beard's the same color mine is. Okay? But when I started working at Livermore 30-odd years ago, I was using a CDC 7600 and a Cray 1 was the big computer coming in. This thing is about 5 times as powerful as the Cray 1 was. And the whole U.S. stockpile was designed on machines before the Cray 1. That's how much technology has changed during my career. Looking forward, the change your students are going to deal with is a lot bigger than the change I've dealt with over the course of their careers. A lot bigger. That's the challenge we're all up against. And I've got to find a way, all the other directors of those laboratories have got to find a way that we can build a workforce that can deal with that kind of change going forward. And we're counting on you to send us the people who can do that. And, you know, going back to your question, and that's about the inspiration. So if you can find things that will get kids so excited about that future that's out there, that they just can't let go of it, that'll help a lot. So thank you.
Dr. McMillan,